The sponsor of Liftoff with Keith is the one and only CompassStrategicAdvisors.com, an experienced partner to help you navigate everything from cap tables to stock option and compensation plans and all types of backroom and marketing services. There is no better friend to the startup CEO than Compass. Check them out at CompassStrategicAdvisors.com. Hello, listeners of the Liftoff. I'm excited about our next guest. He's redefining how the physical world gets understood by machines. Paul Powers is the CEO and founder of Physna, a venture-backed AI company turning 3D data into searchable, comparable intelligence for engineering, procurement, and supply chains. Backed by Sequoia, Tiger Global, Google Ventures, Paul's led Physna into partnerships with Palantir, the DoD, and Fortune 500 manufacturers. He's also the founder of Thangs, the largest 3D model platform on Earth with over 20 million users. And here's an interesting twist. Paul studied astrophysics at Harvard and went on to graduate law school at the University of Heidelberg. Yes, the one in Germany. And before turning geometric intelligence into a weapon against manufacturing complexity, Paul is on to the next big thing with Physna. Please welcome him to the Liftoff. All right, Paul. So hit me straight. How did you start Physna?
Started Physna about 10 years ago. I was aware of a problem in the whole space of dealing with computing the physical world. My background's in law, and I was working in patent law at the time, and realized that although we could query and analyze and understand data that was two-dimensional, whether that's text or that's images, video, even music, we really struggled to do anything similar in the 3D space. And what became clear to me the more I looked into it and tried all the tools that existed in the market was they were really just relying on proxies like images and text, et cetera, to explain parts and define parts and to analyze parts. And that created a big problem for us. And so in trying to find a solution, I called a lot of people who knew about the space and data science and mechanical engineering, you name it, and just was confronted with this unbelievable reality that there is not a way for computers to inherently understand physical objects. Even if you have a 3D model of them or a scan of them, all of those different files are presented in very different ways to computers, and they're really just looking at the surface level and what we tell them about these parts. So realized that just like we needed binary code to digitalize information, like text, video, etc., we need something that can do the same thing for 3D, and that's what Physna is, short for physical DNA.
Right. So with this physical DNA now, computers are much more intelligent. They're picking up, and people that are building products can leverage that information in a much more compelling way.
The difference between using Physna and not, when you're dealing with like raw 3D data, is massive when it comes, especially in the age of physical AI. We've run a number of studies with a number of companies that we work with, ranging from Google to Amazon and Palantir and others. And what we found consistently was that if you take just the raw 3D data as it's presented, and try to use that to train an AI, they don't get a whole lot of information because they can't understand how certain characteristics of parts are related to each other. And so if you can't draw, if you can't compare between things and understand, it's just as difficult as essentially there's no Rosetta Stone. There was no Rosetta Stone. And so because of that, computers really struggled to understand physical objects and learn off of them. If you applied Physna in that process and then use the Physna or the physical DNA to run these analyses, and you understood things like how one part performed versus the other, or how one part was designed versus the other, and or how much one cost, how it was used, et cetera, you really quickly can figure out what part of the object is actually causing that to happen, whether that's something obvious or it's something really unexpected, like a very specific design feature or characteristic that causes things to buckle under pressure, for instance. And so we realized that consistently what we saw was well over 4 orders of magnitude more signal for AI to train off of from the same data just by processing that data through Physna. And so what that means is over 10,000 times faster training for AI and additional insights that you couldn't get before. And that's kind of what the unique thing of Physna is that we just make, we allow computers, we allow AI to understand the physical world. And we're getting out of this era. We're in the era right now of LLMs understanding text. And there's only so much text out there. There's only
Right,
so much human knowledge,
right.
but there's a much deeper wealth and well of the physical world, and they're not separate from each other. You actually can understand text, impact, etc., much better when you understand the physical world as well.
Gotcha. So where is this having its biggest um, impact on a business level? Is it on the product development design side, or is it on the supply chain side, procurement side? Am I just being able to manage smarter, buy smarter, develop smarter? Probably all of the above is what
It's a bit of all
I'm
the above.
hearing.
I mean, really, if you
Yeah.
understand the physical world, in a more natural, deterministic way, it becomes possible to support all of those. And so we have customers that use Physna for like autofill as they design. It predicts what they're designing. We have customers that use us to improve computer vision so they can identify exactly what a part is, not just the category, but very specifically what it is, even in really adverse conditions. And that's useful for part procurement. That's useful for maintenance. That's useful for part deduplication, part analysis. It's also useful for things like um, threat detection, right?
Love
It's
it.
just limited
Yeah.
to that side of things. And then
Well,
we
I'm
also
really
have,
interested. Let's pull back the curtain even a little further. Take an appliance maker. How are you going to help an appliance maker by using Physna versus what they had before?
there's one of the largest appliance makers in the world that used Physna to save over $800 million a year. And they did that because they were able to take their data and look across all the different business units they had and identify where they had a lack of standardization. The very, very similar parts, sometimes identical parts that they had designed multiple times or that they were buying from
Wow.
multiple suppliers. And we were able to say, look, these are all identical to each other. And these ones over here maybe aren't identical, but they're functionally equivalent. They do the exact same function. You can standardize across your business units and save a ton of money because you're ordering things in bulk from your suppliers. You have less SKUs. You have you have pricing negotiation because or pricing power because you can say, look, I'm going to order it a much larger number, and you have less inventory and spare parts to worry about. So for that and many other reasons, that massively saves them money. It's also useful for them identifying who sells parts, how they can manufacture parts, helping them design faster. And now there are even companies in similar spaces who are utilizing Physna to automate the generation of quotes. We have companies that are that are using us to support generative AI for designing. Companies that use us for, in addition to everything else that I mentioned, um, like taking scans of facilities and then running simulations on those. And we have this automated process to turn a 3D scan of an area into a digital twin, meaning they can run simulations and figure out how they can manufacture better, smarter, and cheaper. And so the impact is very broad, all the way from the design phase to
Yeah.
through manufacturing and on to support and maintenance.
Very cool. And is it the same kind of use models with automotive companies, which I understand
Absolutely.
you're
The use
working with?
cases
Yeah.
are all universal because the technology applies to anything three-dimensional, anything physical. So the use cases that we see in appliance and appliance manufacturing apply to automotive, they apply to aerospace. There's many use cases for it. But some of the most common ones really do come down to better procurement, faster procurement, cost savings, spare parts management, wiser decisions while doing part innovation, like while creating designs, understanding the impact of a design element, like this part might cost us more to build, and knowing that before you even finish the design, and being able to design much faster and avoid redesigning. Those are some of the most common use cases that we see.
Paul, I know you have a pretty interesting background with astrophysics. Also, how does this apply in the physical AI world? How does this get integrated with things like robots as well?
It's a great question. So there's a number of ways that we can be integrated. The first thing is the most valuable thing you can do is to simply put the data that you have, your models, in Physna. At that point, you're 99% done. From there, you just use
Mm.
an API to connect any AI tool that you'd like. And that can be an LLM, that can be ChatGPT, that can be Claude, that can be whatever you'd like it to be. And what'll happen is the an understanding of your organization will expand rapidly. A lot of people think that the core use cases that we provide from a software perspective are the full potential of what Physna does, and that's not true at all. We see companies leveraging that physical intelligence in ways that you really would struggle or I struggled with, certainly anticipating, because it turns out that when you understand everything that you deal with, buy, manufacture, et cetera, at a physical level, and you start to see these correlations between how parts are designed, what parts you're using, how they're performing in the field, how much they cost, how they're manufactured, how well they're selling. The types of insights that an impact that can have across your organization is massive. So even if you just want to have an AI that just understands your company better, it's the Physna is a very key component to that. And it's shocking actually to see just how many downstream effects we see from adopting Physna there. So the process
Yeah.
is simple. It's just bringing your data into Physna. And then in cases like robotics, all of what I just said applies. But I would also add that, it's really important to have digital twins that are simulation ready to do things like route planning and improving efficiencies. And that's where the tool that we're working on called Reality Compiler that we've built and we're partnered with NVIDIA and a couple others on building out that technology will allow you to just scan an environment, even with a smartphone. And instead of having this rough scan of sort of what something looks like in 3D, we can take that data, identify everything in there, replace it with the actual models and all the metadata known about them. And now you have a wealth of information of what's in your surroundings. So a robot not only knows how to navigate better, but if it needs to pick up objects, instead of just seeing something that looks like whatever, or something that's of some size, it knows everything about that object, what it's made out of, the density, the wall thicknesses, how much it cost, where it was bought, et cetera. And so it knows how to pick it up, where it'd have to pick it up. There's a lot more intelligence that you can gather when you have that level of intelligence of the physical space versus when you're just guessing or trying to run off basic computer vision.
So this could be basically a standard part for a robot who's in manufacturing, warehousing, supply.
Correct. I think one of the most powerful things Physna can do is take what you already have and just make it exponentially more intelligent. So if you already have a robotics company and you're using computer vision, that doesn't mean Physna is a competing solution. Not at all. Actually, most of the time what we're doing is we're enhancing the accuracy of computer vision. Or if you have digital twins already, it's not that they're obsolete with Physna. It's just that you can regenerate those much faster. You don't have to model them out anymore. They can be produced essentially in real time. And there's a lot of efficiency gains that you get from adopting it. And if you don't have any of that, then the impact that you can expect to see is pretty sizable. On average, we're seeing 40% savings in procurement. So if you have $100 million or $1 billion a year budget, 400 million of that or 40 million of that, depending on your budget, is going to go away, not because you're buying, but not because you need less parts. It's just because you realize that you can reuse the ones that you have already, and you can find better deals.
Paul, the world of manufacturing has gone in a lot of different directions, geographically speaking. There's some feeling that the world of robotics is going to be a new battlefield, but I think AI is generating a lot of new battlefields, really. When you
Yeah.
think about what Physna could represent in that, do you see that there's potential to help America build more of a regain its strength in terms of manufacturing and bring a lot of that back to the shores here? And I know that's a big movement currently, but this could be a real catalyst.
Absolutely. So the inherent issue that you have with manufacturing things overseas, and not even including the tariffs, for example, but also the or any cybersecurity risks or what have you. You also have a cost that's associated with them. You have to ship those parts over to you over to your location, and it's cheaper to do that in bulk than it is to do just what you need it for. So if you're going to buy more than you actually need, and some of that's going to become waste. So the ideal scenario is that you're able to manufacture things as locally as possible, as quickly as possible, and at the to the level that you need. And so there's a lot of advanced manufacturing capabilities that we're seeing be developed. One that everyone knows about is additive manufacturing or 3D printing, but there's others as well. And what enables people to know when they can leverage that technology or what technology to leverage where is that physical understanding. So if we can tell you, hey, this part can be 3D printed and still be used in its intended purpose, or maybe a section of it can, another section has to go through another process. Knowing what has to happen is a major, it massively helps you to determine how can you manufacture that locally without having to go overseas to someone who's essentially acting similar to a general contractor for all things manufacturing. The other thing that we can do is tell you, and we do this all the time, especially with the military, looking at an object, we can tell you immediately, one, does someone sell that part? That might sound like a no-brainer problem to solve, but it's not, because those parts aren't labeled and everyone calls that something different. Everyone has a different part number, and traditional computer vision is not accurate enough for things like washers and screws and whatnot to tell you which one that is. There could be thousands that look similar. So by leveraging Physna, even if you are just dealing with images, for example, that improved intelligence of the physical world of the object that you see in front of you means that you can immediately know who out there sells this part in the United States. It might be much cheaper to buy from someone down the road at the exact quantity that you need than in bulk from China, for instance. And if nobody manufactures or nobody sells that currently, by applying physical AI on top of Physna, or even just using the one that Physna provides itself, we can tell you this is you don't have to guess just because we tell you these are the steps, these are the methodologies required. You don't need to go out and find manufacturers. We've actually built that in, so we can tell you, yes, this is how it has to be manufactured. Here are the companies in your area or that fit your criteria that can manufacture that part. And in some cases, we can even tell you how much they're going to charge you, right? So you immediately have this intelligence of how you can acquire something, regardless of what it is, regardless if it's on the market or not, and all of your options that you have, especially those that are in the United States. That's very, very common in the military, but also increasingly for automotive, aerospace, and other OEMs that benefit from reshoring up their manufacturing operations.
If you were to sit in front of 100 manufacturers, US manufacturers today, would your message be one of, you need to do this now? Would you need to be ready for this down the road? What would be your core statement to them?
I would say that they need to do this yesterday. I think in other countries and in some parts of the world and some industries, people are a lot further along this journey. And one of the problems that we see, for example, in automotive is that China, for instance, is actively undermining our pricing. They're designing faster. In China, in a lot of cases, they're designing next year's car now, not one for 4 years out, and they're keeping the costs very low. If you want to compete with that, you have to be able to design at the same speed. That's why things like generative AI, which we have a massive automaker in OEM in Germany that relies on us for that they rely on Physna to generate the assets for them, because generative AI in 3D does not typically work to the level that you need it to for manufacturing safety.
Right.
But Physna, because of how it works, can. And we've proven that. And so that's one way that you can accelerate your innovation. There's other things Physna does there too. But it's also lowering the costs, because if you're going to compete with the country you're buying all the components from, but you have to pay international shipping, you don't have the subsidies they do, et cetera, you're really never going to be able to win on the cost game. But if you can bring your costs down dramatically and start to find cheaper, onshore alternatives, or even just international alternatives, and you can find out how you can reduce your procurement budget by 40% really quickly, you can start to massively cut away at those differences, those price differences, without having any sacrifice to your gross margin. And so I think that it's something that needs to have been adopted a while ago. And what's frustrating is that you see all these companies are sitting on a wealth of this data. They all have it. And every time that people tell me they don't, we love showing them it's not true. We'll say, look
Yeah.
at what data you do have, and I guarantee you plenty of it's going to be there. And
Yeah.
the opportunities that we discover are massive. And that appliance manufacturer that I mentioned, who we save $800 million a year,
Yeah.
before we engaged, they expected that we would find little to no opportunities for savings. And clearly that wasn't the case. It's you don't know what the problem is that you're dealing with until you know, peel back the layers and take a look inside. And what Physna does is allows you to do that immediately on day one.
Wow, that's special. Um, I wanted to ask as well about this whole notion of 3D printing. You mentioned it a little earlier, and I did a little background, then your name came up. Business name came up. Can you want to do you want to walk me through that whole debate? Now it's moved into a gun debate discussion. It's moved into a legislative discussion. It's a bit of a hot potato, but I want you to kind
Yeah.
of paint the picture if you don't mind.
Absolutely. So first of all, we're extremely pro hobbyist in the 3D printing space. We actually built things, and we owned it until about a year ago. It became the world's largest 3D printing site. With I think we reached about like 25 to 30 million monthly active users, the world's largest database. I mean, there's quite a lot happening on that site, and we sold it. And so we've always been very pro hobbyist. Now that site
Mhm.
doesn't have the version of Physna that can do what you're talking about, which is the identification of parts that are already illegal in some locations, and in those locations preventing someone from accidentally manufacturing them. The debate is all around the concerns people raise are, well, so the law, let's start with that. The law that's going through in New York and California, maybe in Pennsylvania and some other places, basically says, hey, for the parts that are already illegal to manufacture here, we're going to require that 3D printers have a capability on the device to recognize that one of those illegal parts is being manufactured and stop the print. What people I think misunderstood from that was their understanding was, well, you're going to be monitoring what we're printing, that all of our data is going to go somewhere else, and whoever that company is going to end up, spying on us and having our intellectual property. And what if they don't do it right? What if they just say, oh, it vaguely looks like something, and now I can't print things? And there's all these concerns, and I get them; they're very legitimate. Um,
Mhm.
and so the way we got involved with that wasn't because we have a political stance. We don't. We're a company. We're apolitical. We were contacted by Dartmouth long before this bill ever came about, and we were asked more like a academic question. It was, okay, is it possible to reliably identify these types of objects that aren't supposed to be out there? And can you do so in a way that, one, doesn't generate false positives so that you wouldn't be saying, hey, this is a problem when it's not? Two, can you do so in a lightweight fashion so that it could work on a device? And three, can you do so reliably enough that it's not extremely easy to just make a tiny tweak and then all of a sudden it skips the algorithm? So a lot of testing was done, and we said we're happy to ingest whatever data you give us. We'll give you the output, and then you'll have your answer. And what we found was time and time again, it's because of how Physna works, we have to look at every aspect of a 3D model, down to there is no actual limit. It's down to the atomic level if that level of detail is present. So
Yeah.
the wall thicknesses, the materials, the exact geometry, not just the vague appearance of something. We look at everything. And so it was easy for us to say, hey, yeah, we know that looks like a Christmas ornament, but it actually has a machine gun conversion kit inside of it, or part of
Yeah.
it. Or hey, I know that thing looks like it could be something similar to that, but it's not. It doesn't have the right geometric characteristics. You couldn't use it for that. So we weren't seeing false positives. We weren't seeing false negatives. It was very hard to trick the system. You couldn't really do it. I mean, it would consistently find that geometry was present, and it's a very specific signature. It's not like something that's accidentally going to show up on something.
Right.
And actually, there's a really good equivalent for this, which is like, in my understanding, I think in both America and in Europe, there are laws that require regular printers, like 2D, your regular inkjet type printers, and copying machines to prevent you from printing counterfeit bills. Even if they're not connected to the internet, they have technology on the printer that will say, hey, if I see these signatures that looks like it's a banknote, I won't print it. Now you can print monopoly money, you can print fake money, you can do all that all day long, but you can't try to use them to print counterfeit bills. And this is very similar. It's not, there's no communication happening with us. This is on-device capability. There's no flagging, there's no alert to law enforcement, none of that. It's just saying, no, stop, you can't print this thing. And the advantage to that in my mind, and this is not necessarily a company position, it's just thinking of of the pros and cons of this. I actually I collect guns. I love guns. I have a lot of guns myself. I'm a big believer in our right to have them. I don't see this as an infringement because one, this is only happening in places where that is already illegal to do. So this isn't making something illegal that wasn't illegal. And two, what it's doing is actually just giving the OEMs, the manufacturer of those printers, a requirement to introduce a really simple solution that is not very expensive, but it takes the onus off of the hobbyists who today, whether they think they know it or not, they do have to be cautious of the fact that they could be breaking the law, printing off certain things that they might
Right.
not know are actually legal to print. And even if that
Saving them from themselves, kind of.
yeah, and even if that wouldn't hold up in court because you could say, well, I didn't know, it obviously was obfuscated, you don't want to have to go through all that, right? So what we're doing is we're taking away that concern, and that's my understanding of the law. But again, our
Yeah,
company's position is not should this law exist or not exist.
yeah,
It is simply can the technology do this? And the answer is a resounding yes. This is if we couldn't do that, we would be out of business. People rely on us for determining the interchangeability of extremely critical systems from everything from missiles to planes to cars. I mean,
wow,
things that
yeah,
people's lives depend on. If we couldn't tell the difference between an auto sear for a Glock and
yeah,
something that kind of looks similar, but it's part of a Barbie doll, I mean, we would be out of business immediately. So it's a
yeah.
very, very easy thing to solve. And that's basically all we were there to say is it's doable and here's the evidence.
That's great. Hey, before we jump, I do want to ask you, you've gone from astrophysicist to lawyer to startup CEO of a physical AI company on the back of a rocket ship. What's been the biggest surprise in this whole step into the world of AI and running a new company? What's been your surprising moment, your greatest aha?
I think the biggest aha for me is the importance of timing. When we started this company and built out the technology, it's not like it happened overnight. It's always improving. It's always happening. But, you know,
Yeah,
a few years ago, before AI was focal point for everybody, prior to 2022, 2021, um, people weren't really interested in physical AI or how big of a deal it is to be able to understand the
hmm,
physical world. What's really become clear over the past, especially the past 6 months, ever since NVIDIA has been talking about it so heavily, is how important and transformative physical AI will be. And we love that because Physna is an extremely important foundational layer to make physical AI actually work. And the difference between using us and not using us is over 10,000 times more information and faster training. So for us, that's been a big, big takeaway. And I'm very excited about it because it means that we have the opportunity now to actually unleash the potential that we've had for a long time now that the market and the industry and the technology is caught up to adopt it.
that's fantastic. Hey, one last question because it is liftoff, and we like to share some wisdom with our audience, who's also a bunch of founders and startup companies. What's some advice that you would give to a new founder who's entering the market today, maybe entering in the physical AI space?
It's a great question. I think there'd be a lot of different things that I would advise them on. I think the
Yeah,
most important thing for running a business successfully is obviously you need grit, you need determination, you need to think creatively and trust people and be trustworthy yourself. But beyond all of that, you need perseverance. Nothing ever goes as fast or as easily as you expect it to.
yeah,
Things are hard, and you have to find a way to just stay I would almost say naively optimistic, because if you don't, then pessimism will absolutely slow you down. You won't get anything done. You won't make the impossible possible. And that's really what it takes if you're going to enter a space, especially a space that's it's a high tech one where you're pushing the envelope. There's many books on how to do a great job in general, but when you're pushing a specific envelope that hasn't been pushed before, there's a lot of trial and error, and the only way to succeed is just to stick with it. So don't give up.
Paul, that's some great counsel. I appreciate it. And you were on a fantastic ride. Thanks for that. If anybody wants to get in touch with you, they can find you at physna.com, physna.com. And you have a LinkedIn, of course. And thanks for joining us on
Thank
Liftoff.
you for having me. I appreciate it.
Onward and upward. Thanks, Paul. That was great.
Awesome. Thank you, Keith. I appreciate it.
I know you have another call.
Okay, awesome. I will see you soon. Appreciate
We'll
it.
talk soon. Yeah.
Thanks. Take care. Bye.